Imagine a tiny vessel, no bigger than a small car, drifting alone in the dark. It has traveled for nearly half a century, pushed onward by a burst of speed from long ago. This is the story of Voyager, a ghost ship sailing on an endless ocean of black. It left our sunlit shores decades ago, a brave explorer sent to see the giants of our solar system, Jupiter and Saturn. But its mission did not end there. It kept going, hurtling toward a frontier no one had ever crossed. It carries with it the memories of a world it will never see again. A pale blue dot receding in its rearview mirror until it vanished completely. It is now a silent wanderer, a testament to human curiosity, pushing deeper into the unknown. The loneliness of its journey is almost impossible to comprehend. For years, it flew past nothing but empty space, a chilling, silent void. The light from our sun, the star that gives us life, grew fainter and fainter until it was just another star in a sea of countless others. There are no sounds out there, no wind, no air to carry a whisper, just the hum of its aging electronics and the faint crackle of cosmic rays striking its metallic skin. Space is not just empty. It is an emptiness so profound it defies our earthly understanding. Between the stars, there is a vacuum more perfect than anything we can create in a laboratory. It is a place of absolute cold where temperatures plummet to hundreds of degrees below zero, cold enough to freeze the very air we breathe into a solid block. In this void, there is no protection, no atmosphere to shield you from the harsh realities of the cosmos. The dangers lurking in this emptiness are invisible and relentless. The space between stars is filled with cosmic rays, high-energy particles shot from exploding stars and black holes across the galaxy. They travel at nearly the speed of light, tiny bullets that can rip through metal and scramble electronics. For a fragile spacecraft like Voyager, this is a constant storm, a perpetual bombardment that slowly degrades its systems. It is a silent, invisible killer, a form of radiation so powerful it would be instantly lethal to any human being. Beyond the radiation, there is the simple, terrifying fact of isolation. If something were to go wrong, there is no one to call, no rescue mission that could ever be mounted. The distances are simply too great. A message sent from Voyager, traveling at the speed of light, takes nearly a full day to reach us. Our reply would take another day to travel back. A simple conversation would take 2 days. And then there is the darkness. Not the darkness of a cloudy night, but a perfect, unending black. The stars are brilliant, of course, sharp and clear without an atmosphere to blur them. But they offer no warmth, no comfort. They are cold, distant points of light in an overwhelming abyss. For decades, Voyager traveled within a bubble. A giant, invisible bubble created by our own sun. This is the heliosphere, a region of space filled with solar wind, a stream of charged particles flowing outward from the sun. It acts as a shield, protecting our solar system from the harshness of interstellar space. For years, scientists watched and waited, tracking Voyager's position, wondering when it would finally pop through this protective bubble. The moment of transition was not a dramatic explosion or a sudden flash of light. It was subtle, a change in the symphony of particles that Voyager was listening to. In August of 2012, Voyager 1 detected a sudden dramatic change. The solar wind, the familiar breath of our sun that had surrounded it for its entire journey, suddenly dropped to almost nothing. At the same time, the probe was hit by a massive surge in galactic cosmic rays, the particles from interstellar space. It was as if a gentle breeze had suddenly stopped and a powerful cold gale had begun to blow from all directions. The data was clear, unmistakable. This was it, the moment humanity had been waiting for. After a 35-year journey, Voyager 1 had left the solar system. It had crossed the heliopause, the outer edge of the sun's influence, and entered the space between the stars. It was now officially an interstellar traveler. Voyager had become a pioneer in a new reality, sending back the very first reports from a realm that had previously existed only in our imaginations. It had pushed past the edge of the map and began to fill in the blank space labeled "Here be dragons." Attached to the side of each Voyager spacecraft is something extraordinary. It is not a scientific instrument, but a message, a greeting to the cosmos. It is a golden phonograph record, a time capsule carrying the story of our world. If Voyager is a ghost ship, then this is its message in a bottle, cast into the cosmic ocean in the hope that someday, somewhere, it might wash ashore on a distant world. It is a profoundly hopeful gesture, an attempt to reach out and say, "We were here. This is who we were. We hope you are well." The contents of the Golden Record are a portrait of humanity. They include sounds from our planet, the cry of a newborn baby, the sound of rain, the song of a whale, and the roar of a volcano. It carries music from different cultures and eras, from Bach and Beethoven to Chuck Berry's Johnny B. Good. There are greetings spoken in 55 different languages, each one a simple, peaceful welcome. It also contains 115 images encoded in analog form, showing scenes of life on Earth. A mother and child, a city street, athletes competing, and diagrams of our science and our DNA. The creators of the record, led by the famous astronomer Carl Sagan, knew the chances of it being found were infinitesimally small. The record might drift for 1 billion years without ever encountering another civilization, but the act of creating it was, perhaps, more for us than for any alien. It forced us to think about who we are. What single message would we want to send to the stars? What sounds and images best represent our entire species? The Golden Record is not just a message to aliens. It is a message to ourselves, a reminder of the beauty, diversity, and fragility of our own world. In the cold, indifferent void of space, this golden disk is a spark of warmth. For centuries, ancient mapmakers would draw dragons and sea monsters in the uncharted regions of the world. It was a way of acknowledging the unknown, of admitting that beyond the familiar, anything was possible. For scientists today, the space beyond our solar system is that uncharted territory. While they may not expect literal dragons, they have their own set of cosmic monsters to worry about. The things we might find out there are not necessarily hostile life forms, but natural phenomena so strange and powerful they could challenge our understanding of physics itself. One of the great fears is the sheer violence of the cosmos. Our solar system is a relatively calm neighborhood, but the galaxy is filled with cataclysmic events. Supernovae, the explosive deaths of massive stars, can sterilize entire regions of space with lethal radiation. There are rogue black holes, wandering silently through the dark, their immense gravity swallowing everything that gets too close. There are neutron stars called magnetars with magnetic fields so powerful they could wipe a credit card from halfway to the moon. Our heliosphere protects us from the worst of this, but Voyager is now on the other side of the wall, exposed to the raw, untamed galaxy. Scientists also wonder about the very fabric of space itself. Could there be strange forms of matter or energy that we haven't even imagined? Some theories suggest the existence of things like cosmic strings, theoretical defects in space-time left over from the Big Bang that could possess incredible density and energy. The ultimate question, of course, is about life. While the Golden Record carries a message of peace, scientists are cautious. What if the first life we encounter is not friendly? Stephen Hawking famously warned that an advanced civilization might view us the same way we view bacteria. As Voyager crossed into interstellar space, it became our first true deep space probe, an ear pressed against the wall of the cosmos, and what it heard was unexpected. In 2013, scientists commanded Voyager 1 to listen. They sent a command that caused its plasma wave instrument to activate, and for months, it heard nothing but a faint, steady hiss. But then, a massive solar flare erupted from our sun, sending a shockwave of particles racing out through the solar system. Months later, this wave reached Voyager, and something incredible happened. The wave caused the space around Voyager to vibrate, to ring like a bell. For the first time, we heard the sound of interstellar space. The instrument detected oscillations in the plasma, the thin gas of charged particles between the stars. When converted into audio, it sounded like a strange, ethereal hum, a low-frequency tone that rose in pitch. This was the music of the cosmos, the ambient density of the interstellar medium made audible. It was a stunning discovery. Voyager had measured the density of the gas between the stars, and it was far denser than many models had predicted. The empty space was not so empty after all. It was alive with a faint, vibrating hum. This discovery was a moment of pure suspense and revelation. For months there was silence, and then suddenly, a clear and undeniable signal. It was as if the universe had decided to speak, and Voyager was there to record it. This interstellar hum was not a one-time event. As more solar shockwaves have passed by, Voyager has heard this sound again and again, each time confirming its findings. It is painting a picture of a dynamic and complex environment, a place filled with waves, turbulence, and structures that we are only just beginning to understand. These whispers from the void are more than just curious sounds. They are vital clues about the nature of our galaxy. Voyager, in its lonely journey, has become a pioneer of a new field: interstellar meteorology. It is reporting back on the weather between the stars. The journey of Voyager cannot last forever. Its power comes from a device called a radioisotope thermoelectric generator, which essentially runs on the heat from decaying plutonium. It is a remarkable piece of technology, a nuclear battery that has powered the spacecraft for nearly 50 years. But its fuel is finite. Every year, the power it produces drops by a tiny amount, a little less than a watt. This slow, inevitable decay means that Voyager is living on borrowed time. It is a slow fade into silence, a long, drawn-out goodbye that has been unfolding for decades. Engineers on Earth have become masters of conservation, fighting to keep Voyager alive for as long as possible. One by one, they have been turning off its instruments to save precious power. Heaters for scientific cameras, systems that are no longer essential, have been shut down forever. It is a painful but necessary process, like deciding which senses to give up to keep the heart beating just a little longer. Each shutdown is a small death, a loss of one of the ways Voyager could perceive the universe. The signals themselves are now incredibly faint. By the time they reach Earth, they are billions of times weaker than the power of a watch battery. It takes a global network of massive radio antennas, the Deep Space Network, to even detect them. The team's goal is to keep at least one scientific instrument running until around 2025, and to keep communications open for as long as possible after that. Sometime in the next decade, perhaps around 2036, the final moment will come. The power will drop so low that Voyager will no longer be able to aim its antenna at Earth. Its last faint whisper will be sent, and then there will be only silence. It will not stop moving. It will continue its journey through the Milky Way, a silent, derelict ghost ship. It will drift for thousands of years before it even comes close to another star. Its mission of discovery will be over, but its journey as a silent ambassador, carrying its golden record, will have only just begun. Why do we still listen? Why do we strain to hear the fading whispers from a machine that is nearly half a century old, drifting billions of miles away in the cold and the dark? The answer lies not just in the science, but in what Voyager represents for humanity. It is our ultimate adventure, our most daring act of exploration. Listening to its final signals is like standing on the shore, watching the last flicker of light from a ship that has sailed over the horizon. We listen because it connects us to the grand, cosmic journey we are all a part of. What secrets might its last words reveal? As it travels deeper into interstellar space, it continues to measure a region no other probe has ever reached. Its final transmissions could hold clues about the magnetic fields that shape our galaxy, or the true nature of the boundary that separates our solar system from the rest of the cosmos. The act of listening is an act of hope. It is a declaration that we are a species that looks outward, that we are driven by curiosity and a desire to understand our place in the universe. Voyager is an extension of our own senses, a part of us that has journeyed where we cannot. To stop listening would be to turn our backs on the unknown, to admit that the frontier is too far, too dark, too empty. As long as we can hear its faint signal, we are still connected to that frontier. We are still explorers, still reaching for the stars. Ultimately, Voyager's last goodbye will mark the end of an era, but not the end of the story. Its journey will continue in silence, a testament to the moment when a young species on a small blue planet dared to reach out. We listen for its fading signal because it reminds us of what we are capable of. It reminds us of our own courage, our own ingenuity, and our own unending desire to know what lies beyond the next hill, beyond the next ocean, and beyond the next star. We listen because in its lonely silence, Voyager speaks volumes about who we are.